Good morning, everyone, or afternoon, depending on where you may be calling in from. My name is Megan Balding, and I'm with the USC Viterbi School of Engineering. It is my pleasure to welcome you here today for our spotlight presentation on our graduate programs in systems architecting and engineering. I am so excited to introduce my co-presenter today, Professor Azad Modni. Professor Azad Modni will be taking over the questions very shortly and responding to questions regarding the Master of Science and Graduate Certificate Program in Systems Architecting and Engineering. So thank you, Professor Modni, for joining us today. And thank you to those of you attending the session. I look forward to hearing your questions in just a bit. So before we get started with the formal presentation, I do want to just do some quick housekeeping items. We will be sending out a copy of the slides after today's presentation, so you don't have to worry about copying down the information that we will be sharing today. It does take us about 1 to 2 business days to get those out to you. Now, in terms of asking questions in the session today, we highly encourage you to ask questions utilizing the Q&A panel. That will allow me to monitor the questions the best and direct those questions to Professor Bodney as needed. In terms of today's program, I will be providing a very quick overview of USC and the Viterbi School of Engineering, but then we'll really be focusing on the Systems Architecting and Engineering program. We'll go over some frequently asked questions that have been directed towards the program in the past, but then we'll be opening it up to all of you attending today and allowing you to send over your questions and any inquiries that you may have. So in terms of a quick introduction, the University of Southern California is the oldest private university in the Western United States, founded in 1880. We have about 46,000 students, about 19,500 undergraduates, and about 26,500 graduate students. We have about 4,700 full-time faculty members and a diverse student population with students coming from all 50 states and over 100 countries. The campus itself is located in Los Angeles. We're just south of the downtown LA area. In terms of the Viterbi School of Engineering, we consist of 8 academic departments. We have 189 tenure-track faculty, of whom 17 are full-time. Of our full-time tenure-track faculty are members of the National Academy of Engineering. We have over 90 National Science Foundation Career, National, and Presidential Young Investigator Award winners. Our student population within the Viterbi School is about just under 2,900 undergraduate students and just about 5,500 graduate students. Graduate students, of course, consist of our masters, both online and on campus, as well as our PhD doctoral programs, which are traditionally on campus, and our graduate certificate offerings, which we'll be getting into today. In terms of the research within the Viterbi School, there is a significant amount of research housed within the School of Engineering. We have over 35 research centers and are considered a leader in funded research, both within the university at large, as well as within our higher education counterparts. More than $212 million in research expenditures are used annually. So as you can see, a lot of exciting things going on within the research sphere. So without further ado, I'd like to introduce Professor Azad Modni. Professor Modni is a member of the National Academy of Engineering. He's a Dean's Professor within the Department of Astronautical Engineering. He is also the Executive Director of the SAE program here at the Viterbi School. We've also included some highlights here of his career and most recent awards, of which he has many, a very accomplished faculty member within the Viterbi School. Professor Modni has received the 2021 IEEE AESS Judith A. Resnick Space Award, the 2020 IEEE SMC Norbert Wiener Award, 2020 NDIA Ferguson Award, 2019 IEEE AESS Pioneer Award, the 2019 AIAA ASEE Leland Atwood Award, and the 2011 NCOSE Pioneer Award. A lot of acronyms there. He's also a fellow of the AAAS, AIAA, IEEE, NCOSE, IETE, SDPS, and WAS. When he had some spare time, he also developed a number of the core courses within SAE, including SAE 549, 547, 548, and 546. So I can't think of anybody better to speak to the program than Professor Modney. Professor Modney is also the author of three of the textbooks that are a core part of our courses. He, of course, can speak to these better than I ever could. But as you can see, these are some of the textbooks that will be part of the coursework if you do become a student here at the Viterbi School within one of the systems architecting and engineering programs. So Professor Modney, thank you again for joining us. I hope you don't mind, but I think we'll just jump right into the frequently asked questions unless you wanted to say something prior to the questions section.
No, thank you, Megan. I think we want to go with answering questions because I think that's what's on people's minds. So let's go ahead and have people go ahead and ask questions.
Great. So we're going to start with some kind of arranged questions that I think will help to just give a good overview of the program and are things that we've heard a lot of times just speaking to prospective students. After we've gone through these, we'll then turn to you, those of you in the audience that are attending today, to go ahead and send over any questions. For those of you that missed the beginning of the session, we are asking that you send over your questions in the Q&A panel. So, Professor Modney, to start it out, what makes the Systems Architecting and Engineering program unique?
So, the thing that's interesting to know is that you will notice in the title that we call it Systems Architecting and Engineering. And we don't subsume systems architecting within systems engineering. And the reason is that these two disciplines require different kinds of thinking. Systems engineering is much more analytic, it relies on analytic problem solving, decomposition techniques and such. Systems architecting, on the other hand, is much more integrative. It relies on synthetic thinking, lateral thinking, associative thinking and such. You need both types of thinking to be a great engineer, and therefore we have this distinction, and the distinction is not without a difference. The difference being the way we think about things is different from these two things. You get your left side of the brain and right side of the brain working together, and I think you're in a pretty good place. So the program is also unique in terms of the fact that the field of systems architecting was pioneered by my predecessor, Eberhard Rechten. And his book is a required text in this, as the books that I've written in the same area as well. We have 3 NA members, which is the National Academy of Engineering, myself, Eb Rechten, who's of course passed, and Professor Barry Bain. This is the only program where we have 3 NCOSE Pioneer awardees. Again, it's myself, Eb Rechten, and Barry Bain. We have several fellows of professional societies in our group, and as you can see, and we're active in several professional societies, including NCOSE, IEEE, AIAA, and CSER, which is the Conference on Systems Engineering Research. This is a conference that we co-founded with the Stevens Institute of Technology, and it has become the go-to place for people who are interested in systems engineering research. I also co-founded, and I'm the organizer of this conference. I also co-founded and have chaired since 2013 the IEEE Systems and Cybernetics Technical Committee on Model-Based System Engineering, which is one of the main developments in systems engineering in the last decade. What's also unique about our program is that we exploit the synergy between what we teach and what we conduct research, so that research feeds new material into our courses on an ongoing basis, and teaching uncovers new areas for research because of the questions that you ask of our instructors. And when you ask questions that we feel that we do not have an adequate answer, that's a trigger that says we need to do some research to come up with better answers for those things. Now, one of the things that I did and instituted in the course is that I rely heavily on storytelling techniques as opposed to just presenting facts and figures. So if I were to talk about the Global Positioning Satellite, I wouldn't tell you what it is and what its specifications are and what it does, but rather I tell you the story, how it came to being, when people were sitting in the, in their laboratory in the advanced physics lab, and they heard about the Sputnik, and therein the story starts. And so what happens is people have the entire story that goes with the, the system that we are studying. And while people may forget facts and figures, they will never forget a good story. And so this is how we make the material, if you will, sticky. We have top-notch adjunct faculty. The faculty that we have are from top universities, MIT, Berkeley, UCLA, USC, and all the top other institutions in the country. And they're all from major position holders in aerospace and automotive companies. So there are people from like Boeing, Aerospace Corporation, Jet Propulsion Laboratory, etc. This program was named the Top Information Systems Master's Program in 2017 by Masters in Data Science. And what you see at the bottom is a helpful link that you can go there and browse and see other things that you can pick up. And if you have any questions at this point in terms of what makes the program unique, feel free to ask. If not, we can go on to the next. Okay. So here are some factoids for you, especially for the master's students. We're particularly active in the INCOSE Los Angeles chapter, and we have a student division here. And this gives you an opportunity to network with other students and faculty. The INCOSE Los Angeles student chapter is one of the most active chapters in INCOSE and has been winning awards for the last decade. And we are pretty active in this chapter. And people that come there are people from the space industry, aerospace industry, some people from the medical devices and energy sectors as well. Every 3 years, we host the Conference on Systems Engineering Research. And there you have an opportunity to present your technical research papers, network with both students, both in the US and abroad, as well as researchers from the US and abroad. We also support the INCOSE Los Angeles mini conference and the regional mini conferences. And again, you have a chance to network and present your material to industry professionals, students, and faculty from the Los Angeles region. Now, what's interesting about these factoids is that you get a chance to see what other schools are teaching, what other students are learning, where they're working, what they say about the jobs that they have. And so it kind of gives you a cue in terms of where you might want to focus on once you get your master's degree and you want to go and get a job in a different place, or you want to make a change of scenery and go from one job to the other. There's a good place to pick up a lot of that intelligence along the way. Let's go on to the next. So the next is what programs are available. So let's go into that.
Great. Thank you, Professor Madni. Yes, I think the next couple slides we'll talk here about the actual curriculum within our master's and graduate certificate programs. So I'm going to just head through, Professor Madni, this is a list of the, and for those of you attending, the programs that are available in systems architecting and engineering. We do have individual slides that will outline these program areas. Of the 4 programs listed, 3 of them are available online through our Dennett Viterbi online delivery option. All right, Professor Madni, I'll let you take it from here.
Okay, so here are some of the required courses that you see. And the first one that you see there is SAE 560, which is the Economic Considerations for System Engineering. This particular course is specifically directed to system engineers. If for some reason that course happens not to be offered in a particular semester, and you are trying to graduate, then you can take a backup course, which is ISE 460, which is a more general course on engineering economy. But it is the case that most of the time, if not always, that 560 is offered. So you don't run into that problem. But sometimes what happens is people are wanting to take a course in summer time frame or something like that. So we give them the latitude that they can take ISE 460 if 560 is not being offered. Then we have SAE 541, which is the foundational course on system engineering, which gives you the theory and practice. A lot of the material that you see in this course and that you will read about and hear lectures on are related to the INCOSE handbook, because that's what is kind of the best practice that we have in the field. Once you've done that course, then you can take the advanced topics. And here this is where you have much more rigorous material being presented, like decision theory, constraint theory, complexity theory, and various things in system engineering to handle complex systems whose behavior you cannot predict, by using typical system engineering analytic methods. So that's when you cover those topics are covered in SA 542, which is advanced topics in system engineering. Then we have SA 549, which is the course that you come into that's the first course you take when you join the program. This is the flagship course that basically led to the foundation of the entire program. And systems architecting, we cover the various methods by which people perform systems architecting. We cover architectural frameworks. We cover a whole bunch of examples from various domains so you can see how architecting can vary from one domain to the other. We talk about what kinds of analogies you can exploit in systems architecting that can help you with architecting a system. So for example, if you're architecting a cybersecurity system, rather than start from scratch, you could look at the human immune system as an analogy on which you can base your architecture. So therefore, those kinds of analogies and that kind of associative thinking is what we bring to bear in SA 549. Then we have two additional very important courses, and in the subsequent years, we will make them both compulsory. The first is model-based systems architecting and engineering, and the second one is system of systems integration. Right now, you can take one or the other, but in the future, we will ask that you take both because of the demand for the courses, the value that they provide, and how core they are to the kinds of jobs that you would be wanting to go to and what the job requirements tend to be. Then we have what you call elective courses. There are 6 units. You take one course of 3 units in the technical management area and one course in the general technical area. In each of these areas, we provide you with a list of 30, 40 courses for you to choose from. If for some reason one of those courses does not fit your thinking and you have something else in mind and it happens to be related, then I will go ahead and approve that on an exception, on a waiver basis. I'll give you a waiver for that. But in general, we don't experience that. People find ample opportunity in the courses that we have in each of those categories to choose from. So let's go on to the next.
Professor Mani, before we do, we did get one question, and thank you to everyone asking your questions in the Q&A. There are a couple questions that came up on the curriculum that I thought we could just take a second. The first one here, you did discuss it, but I think maybe a little bit additional information might be helpful. This individual is asking how much emphasis is placed on model-based systems engineering in this program, throughout the program.
Okay, that's very good. So model-based system engineering is becoming a central theme in this program. That's why we call our program, the course that we have is called Model-Based Systems Architecting and Engineering, because we extend the use of models in systems, from systems engineering into systems architecting as well. In addition, there is a convergence going on between model-based system engineering and digital engineering, specifically concepts like digital twins and digital thread. And so we combine those concepts and we present those. So this program has a growing emphasis in both those areas, and we may end up offering additional courses in these, possibly in digital engineering and the linkage to model-based system engineering. And as you know, I have mentioned this to you, I was the founder of the IEEE Model-Based System Engineering Technical Committee, so this is something very close to my heart. And we have some of the top people teaching MBSE in the program from Jet Propulsion Lab, Aerospace Corporation, Boeing, and several other places. And right now, it's being taught by somebody from Aerospace Corporation, and it has been taught before by people from Jet Propulsion Lab. I taught the course for many, many years before I handed it off to others to follow that, because I can't teach every possible course, but I'm always available to answer any question that come up in those courses. So I hope that answers your question. Model-based system engineering is going to only continue to grow in emphasis in this program, because that's where the field is headed.
Thank you, Professor Mani. I think we can go on to the technical specializations area at this point. And to everyone asking questions, thank you. I'm going to kind of throw them into the conversation where they best fit. So don't think I won't get to your question. I'm just going to make sure it kind of goes with the flow of this presentation. So thank you so much, Professor Mani. Do you think we could talk about the technical specialization areas now?
Yes, so this is the technical specialization area, and what you see here is just a representative area. This is by no means exhaustive. It's meant to be just representative. But you can specialize in aerospace and mechanical engineering, You could do things in AI, machine learning, neural networks, that sort of stuff. You could specialize in automation and control systems. You could have, if your focus is electrical engineering, then you would focus on communication and signal processing. And of course, since you're taking 9 units, that means 3 courses, you'll have pretty good mastery in terms of having vertical depth in those areas. We also have things like computer information systems, construction, because people specialize in those areas. Some people want to go into engineering management, so we accommodate them. Some people are very interested in integrated media systems, and others in manufacturing systems. So we have essentially, I'm doing research right now for NSF in model-based system engineering methods for manufacturing, advanced manufacturing methods. And then we have, of course, we had the network-centric systems emphasis, which now has given way to more cloud computing and things of that nature. And we always accommodate people who want to do software process architecture. This is where we have the intersection with computer science. And so you can take courses in that specialization. But also we give you the opportunity that if you don't want to go into any other specialization, and in fact, you really, really want to specialize in systems architecting and engineering, then you can take a whole bunch of systems courses right from SAE itself. So you have the luxury to stay within the fold of systems architecting and engineering, but you have the option to go outside and take 3 courses from any of these areas, including many more. And I'm not going, like, there's a whole bunch. You can go into business analytics, you can go into biomedical engineering. All those things are options there. But here, this is just a representative set to let you know that you have the option to specialize in whatever area you happen to be. So somebody coming from Medtronic, like, for example, a biomedical engineering devices company, they would be taking 3 courses in biomedical engineering over here. If somebody's coming from, if you will, the Kaiser Permanente or something like that, and they want to specialize in healthcare, then they would take 3 courses in healthcare systems. So we make that accommodation for students, and that's the flexibility, and that's the beauty of this program, which is why people like it. So here are some of the required courses that you see. And the first one you see is the economic considerations of systems engineering, and I've talked about that. You also have a choice of taking project management if you want to do that, and leading management teams. And those are 2 outside courses outside of the SAE program from the ISE department. And the rest of them are all within system engineering. The last item that you see there, SAE 574, that course has been discontinued. So that should not be on there. But it probably has to be deleted from the catalog. So that's what we need to do. But that course is being replaced by some new courses. For example, adaptive cyber physical human systems. This is going to be a major course, and we have the material, we have the instructor ready, we have the content ready to go. It's our plan to offer this course. We put this course together from the research that we have been conducting for the Department of Defense and the other services, and this is a very, very hot topic. So it's adaptive cyber physical human systems, and this is probably a more accurate description of what's going on today, and replaces the older term, which was adaptive human machine system. We are making a distinction here between cyber and physical, and the tight coupling between the two and the implications of that in architecture and such. So I wanted to kind of share that with you as well, that this course is coming. Let's go on.
Thank you, Professor Madni. And that was my mistake. I went through the slide pretty quickly there to just confirm this is the curriculum for the graduate certificate in systems architecting and engineering. And just so you all know the difference between a master's and a graduate certificate, the graduate certificate is about half the units of a master's degree program, and is really, designed for a variety of different reasons. For that, someone might want to start with a graduate certificate. For instance, if you have a master's degree already and maybe don't want a second master's degree, a graduate certificate is a great option for you. Or if you're maybe thinking, okay, maybe I do want to go back for a master's degree, but I'm not sure if I can handle a full master's degree curriculum, then, the full 30 units, then a graduate certificate is a great way to start. And you can go from there. Sorry if you're hearing some background noise, I apologize. If you start with that graduate certificate, you can then apply to the master's degree program and have those courses applied toward the master's degree program at a later point. So definitely a great option depending on kind of your overall needs.
Yeah, and I think what what Megan said is exactly right. A lot of students will start off with a certificate. They'll do the 15 units, which is basically 5 courses from this, and they do well, and they feel more encouraged, and so they feel that they can make the commitment and go ahead and finish the master's degree. So it kind of gives you a checkpoint, because you don't know, many of the people that are in this are distant learners, so they have families and things of that nature. They don't know how much of a time commitment they can make. This is a good way to test that out. And if you do well and you're able to maintain your schedule and you're able to continue to work and not have it interfere with your personal life, then you can take the certificate, as a start, is a halfway point, and then go on and complete a master's degree, in which case some of these courses would transfer. So that's the important thing to realize. And as I mentioned, that this is a certificate, you don't have to take all these courses, you just take 5 of these courses. But the one that you see at the bottom, 574, that does not exist right now. It will be replaced by cyber physical system or cloud computing in the future.
Perfect. Thank you, Professor Madni. The next program here that I was hoping you could maybe discuss a little bit is the Graduate Certificate in Software Architecture.
Yeah, so this is a joint program between the SAE program and computer science. There are a lot of people who are interested not just in model-based systems engineering, but also model-based software engineering. They're also interested in not just systems architecting, but also software architecting. And so to create something which allows these people to master the area of software-intensive systems engineering, we have the certificate. It's pretty popular. And so it covers 4 things. It has 2 courses from computer science, which are requirements engineering and software architectures. And then it has 2 courses from systems architecting and engineering, one being model-based systems architecting and engineering, and the other being systems architecting. So this is this is the required course. And then you have an elective that you can take, which is 3 or 4 units. And we have an approved list of courses from which you can choose. So again, like I say, there's plenty of options there. You shouldn't have any problem in choosing one that fits your needs.
This last one here is the Graduate Certificate in Network-Centric Systems.
Yeah, this one is one that we are not offering at this point. We used to offer it for a long time. This certificate will eventually be changed, like I said, but it shows on the catalog, so we are forced to show it right now, but this is not something we are offering at this point in time. When the catalog gets updated, this certificate will go away. It will be replaced by something much more current.
Right. Yeah. So everyone attending today's session, if you are interested, please do check back with our team in the next term if you're interested in applying in the future, and we can share any updates to these programs with you at that time. All right, so for the next section, Professor Madni, what type of academic background are you looking for in a successful applicant, and who are some of the typical students in your program?
Yeah, that's a great question. So the types of students that we get, a third of them are on-campus full-time students. 2/3 of them are people who work in industry. And when I say work in industry, I mean they could be working in government, they could be working in research labs, they could be working in aerospace companies, automotive companies, medical devices companies, healthcare companies, transportation and communication companies. So all of those people. We used to say that it's nice to have a little bit of practical experience before you take this program, but it turns out, and I found this and I've tracked this closely, that is not necessary, because the people who are full-time students without the prior background in any of this do just as well as the others. So therefore, there is really no requirement that you have a few years in industry, but we recommend industry experience, but it is not required, because I've seen no difference in grades between full-time students with no experience and people who come with experience. And I think it's because of the way we present the material, which is so self-contained, that people who are full-time students without industry experience catch up very quickly. So that's an important thing to remember. We ask for people to have a technical degree, which means an undergrad degree in engineering, math, or hard science from a regionally accredited university. So that means that it has to be something that is approved in terms of their curriculum, and not some of the, without naming names, not some of the things that you can do online and do those courses. It has to be an approved, accredited program, and people can be admitted from that. And that's the 99% of the students that apply are from there. Every once in a while, we get somebody from one of those other places, and of course, they don't get admitted. We ask for a cumulative undergrad GPA of at least 3.0 on a 4.0 scale. That's recommended. In some cases, if you're under 3.0, but you've taken quantitative courses, we might make an exception. But that's on a case-by-case basis. The GRE is not required for admission to fall 2021, and that's a very important thing. So you don't have to worry about that. Sometimes that people view that as a stumbling block, but you don't have that requirement anymore. And applicants applying in future terms will need to clarify the GRE requirements for that term. We don't know exactly how that's going to transpire down the line. But at this point in time, if you're applying for the fall, there is no GRE requirement. You need to supply your resume or your curriculum vitae, which is a little bit more extensive. You need to provide a personal statement as to why you want to take this particular program, or why you want to, what is it that you hope to get out of it, how it fits into your personal agenda, whether it be your career or in terms of your job description. We ask you to supply 3 letters of recommendation. They could be from people you work with, people that are your supervisors, etc., or a former professor. That's all completely legitimate. And international applicants will provide, of course, evidence of TOEFL.
Perfect. Thank you, Professor Madni. I did include here, just as a point of reference, the option to waive the GRE in the future. So as Professor Madni mentioned, the GRE, for those that have applied to fall 2021 are, as we'll talk about in a few minutes, may be eligible for an extension for fall 2021. The GRE is not required. We do not have information for future terms at this time. If in the future, if you are choosing to apply at a future term and the GRE is required, there is a GRE waiver specific to systems architecting and engineering. So I always like to make sure that's very clear. This waiver is only for systems architecting and engineering. There are 2 ways to waive the GRE, which we've outlined here. I won't get into it in too much detail because it doesn't apply right now to the fall 2021 semester, but in the future, it is something to reference if the GRE again becomes a requirement. The following additions, we don't have to spend too much time. As I mentioned, you'll be getting these slides following today's presentation, but we do go through the application criteria for each of the individual certificate programs. There was a quick question here, Professor Madni. If you don't mind, I'm just going to jump in and answer it real quick because it was relevant to this section.
Sure.
So the individual here asks if you are interested in the graduate certificate program, do you apply to the master's degree as well? And the answer to that is yes. So these are 2 separate degree programs. You will apply separately to them. So if you are interested in the graduate certificate and starting that way, you can go ahead, apply directly to the grad cert. And then if you choose to at a later time pursue the master's degree, you would go through the application process again for that master's degree program. So into the next question here, Professor Madni, what types of job opportunities are available to graduates?
Okay, so the graduates from this program end up working at places like SpaceX, Boeing, Northrop Grumman, Raytheon, in the aerospace sector. They work at FFRDCs, federally funded R&D centers, such as the Aerospace Corporation, and also laboratories like Jet Propulsion Lab, MITRE, RAND Corporation, etc. And they also work in automotive companies, such as General Motors, Toyota, and such. And then they work in medical devices companies, such as Medtronic, and of course, people from healthcare, like Kaiser Permanente, people from Veterans Administration, and then of course they work in various government positions in Palmdale and various other places in supporting aerospace and defense programs. So there are opportunities from all over, and this is a target-rich environment for jobs, and particularly in the aerospace and defense sector. And as much also for those of you specialized in things like interested in going into medical devices or healthcare, there are plenty of opportunities there as well. And we are picking up more and more students now in the automotive sector because model-based system engineering and these methods are being increasingly adopted in automotive sector, and they're making some great inroads with different methods and different ways of thinking, but basically the same common theme of model as the authoritative source of truth, and model is the basis for creating documentation as such. So yeah, I think there's no dearth of opportunities.
All right, so thank you, Professor Mani. That was really helpful. The last question here that I think we'll address, if you don't mind, Professor Mani, I'll jump in and just kind of go through these
Sure, go ahead.
slides quickly. And then thank you all again for asking your questions. I see them coming through and we will get to them shortly. Really quickly, the question is, can I pursue the program in systems architecting and engineering online? And as Professor Madni mentions, a good number of our students are doing that as they've chosen to continue working while pursuing the program. So as we saw earlier, these are the programs that are available online. The difference between, an online or on-campus delivery is something I wanted to just quickly touch upon. The differences and similarities is what I should say. So in terms of our on-campus students, I like to just say this is, talking in generalizations because, every student is unique and there are kind of students that fall into different areas. But generally our on-campus students are full-time students. They're taking around 3 classes per semester and completing their degree in about 1.5 to 2 years, taking classes during the summer as well. Our online students taking their classes through our delivery method done at Viterbi are generally working full-time. So they're taking 1 to 2 classes per semester, and it takes them about 2.5 to 3 years to complete their degree. Now, how DEN works, or the DEN at Viterbi or online program works, I think that's a really good question to ask as you kind of compare and look at different programs that are out there. At the Viterbi School of Engineering, our programs are the same. So when you apply to the Master of Science in Systems Architecting and Engineering. Once admitted, then you define yourself as someone that will be coming to campus or someone that will be pursuing the program via online delivery. So you're admitted to and are pursuing the same exact degree program. The difference comes in how you're viewing your weekly lectures and submitting your homework. In terms of viewing the lectures, again, you're registering for the same class that's happening on USC's campus. Obviously, in normal times, this past year has been a bit of an anomaly. But in normal times, when we have classes on USC's campus, you as a DEN at Viterbi student would enroll in the class. You would have the option to view the class live as it's happening on USC's campus via WebEx or a similar Zoom or other delivery system. You could ask questions, be an interactive participant. If that doesn't work with your schedule, and what most of our online students choose to do is view the archived lecture. So a few minutes after the lecture has been completed that day, you have the ability to view the archived lecture when it fits best into your schedule. So in the evenings or on the weekends, but you do have to stay on top of your class schedule. You are following the same syllabus. Your homework and final and midterm and project expectations are going to be exactly the same. There is no difference. You're just pursuing the program from a distance. So homework is submitted electronically, but again, according to the same deadlines. And exams are done at proctored locations in your area. And again, as I talk through this, just please note that this is during normal times. Obviously, as we're in the midst of this pandemic, things have been altered, but we hope to return to normal very soon. And so with that in mind, exams would return to be an in-person requirement at a proctored location near you. If you live near Los Angeles in the greater LA area, you would come to USC to take those exams. This is a quick snapshot of some of the similarities and differences between our on-campus and online delivery. But really, as you can see, the main difference is how you're pursuing and how you're viewing your lectures. So you're either viewing them in person on USC's campus or from a distance. The application requirements, the syllabus, the exam requirements, the unit requirements, and ultimately the diploma you receive is the same regardless of your delivery method. A couple other quick items for those of you that might be interested in the DEN at Viterbi online delivery. There are 2 things I want to mention here: limited status enrollment, which allows qualified candidates to begin taking classes in the next available semester, which would be summer. So if you are qualified, you can begin taking classes as early as summer 2021. As a limited status student, you can take up to 12 units of coursework. that can later be applied towards a degree program if admitted. So you still have to go through the formal admission process. Limited status just gives you the ability to jumpstart your coursework while you prepare your application. Now, there is an employer reimbursement deferment program. So if you're receiving tuition assistance from your employer, this is a great option to look into to avoid out-of-pocket expenses during this semester. Now, after this presentation, we hope you walk away with, the desire to apply and to get started. So we've provided you with a few quick items in terms of next steps. In terms of application cycles, if you are interested in pursuing the program online via Viterbi, there is currently an application deadline extension available. The final deadline was January 15th, but if you're interested in applying for fall 2021, and if your intention is to pursue the entirety of your degree online via DEN, you can contact our office for more information on applying to the fall semester. Now, the next available semester to apply following that, if you are interested as an on-campus student, or if the timeline for fall doesn't work for you, will be spring 2022. The application should be available in early July, and the deadline for scholarship consideration for on-campus students is August 31st, and the final deadline for all students is September 15th. The next steps in terms of applying is to review the application criteria on your program of interest website. So here we provided a link to the degree program options within Systems Architecting and Engineering. And again, as I mentioned, we'll be sending out these slides. Some quick steps in terms of getting started. We do have a virtual campus tour. If you're interested in checking out the campus to get started on the application, we've included that link. For those of you interested in DEN, your options at this point in time are either to apply for formal admission for fall 2021 and to contact us for more information, or to get started this summer as a limited status student. All right, so with that, it is time to address all of your questions that you have been diligently sending over. So Professor Mahdi, the first question we have here is if Cameo tool, is Cameo tool leveraged in any of your SAE courses? And if not, what other MSBE tool might be used?
No, the Cameo tool is in fact used, but because we have what you call academic licenses that students can use. It really depends on the instructor. There are several instructors that teach MBSE. Each one of them a different relationship. Some of them have a relationship with, NoMagic or Dassault, as you know. Some others have a relationship with some others. But Cameo is a popular tool that's used. The people that teach the course are Mark McKelvin from the Aerospace Corporation and Michael Sievers from Jet Propulsion Lab. And we have arrangements and with different academic licenses and things like that. And those vary because those things expire. But it really depends on the instructors. But Cameo is the popular thing. I use that in my research in my lab with my students, and it's also used in our courses. Yes.
Perfect. So the next question here is from an international student who whose inquiry is whether it's possible to do an internship or a co-op during the program. And I can quickly just touch base on kind of the logistics of that, and then maybe Professor Mahdi, you could then jump in with some of the internship opportunities you've heard of from your students.
Sure.
In terms of the logistical aspects of that, the MS in Systems Architecting and Engineering is a program that is eligible for the OPT STEM extension. So OPT and those aspects are eligible for this degree program. You also have the opportunity to connect with our, and this is for any student, whether you're international, domestic, on campus, online, you have the ability to work with our career services office. We have a career services team specific to the Viterbi School of Engineering, who provides a number of opportunities, including career fairs, resume review, guidance for you throughout the process to find opportunities that may be available, whether it be for internships or employment upon graduation. So that's some general information, but Professor Mahdi, would you mind just maybe touching upon maybe the internships and experiences some students have had while in the program?
Sure. So we have interns who from time to time work in our lab. Our lab is called Distributed Autonomy and Intelligent Systems Laboratory. We work in the area of autonomous vehicles, self-driving cars, for example, and so research in that area in terms of hardware, software test beds, different algorithms to steer the car, so it's the brain of the car, so to speak, how to avoid obstacles and all that sort of stuff. So there's a whole that segment that students get exposed to. We also have the opportunity to work on multi-UAV swarms. So for example, unmanned aerial vehicles, small ones like quadcopters, where students work with them, they build them. We have 3D printing capability where we can build our own systems and fly them, and try different algorithms to perform various kinds of missions like search and rescue, as example, for example. So when people get done with that, they have come with hands-on experience. They'll go into their job situation. So you have a person who's going into Northrop Grumman to work shortly, who's been working in the lab for about a year, and when the person arrives at Northrop, he'll have all that experience to back him up, which I think is a good thing. So it's on a case-by-case basis. It's a function of what research programs we have at the time, and and we can then bring the students into the lab. Now, when I talk about these internships, we're talking about unpaid internships. In some cases, we can even have paid internships on research programs, depending on what the contract is and whether we have negotiated such a specific role on that program. So I hope that helps.
Perfect. The next question is there a PhD option for systems architecting and engineering? And and then if you could expand on that, and then also if the second part of that question is if the MS in systems architecting and engineering prepares you to pursue a PhD.
Okay, that's a good question. We have the PhD degree option. It's a specialization within the astronautical engineering department, which the department has two options. You can go in the astro direction, or you can go in systems direction. If you go systems direction, then you would be doing a PhD in the specialization of systems architecting and engineering within astronautical engineering. The MS program does prepare you. It's a necessary step to be able to apply. But then there are two other things. You have to have some research credentials. You have to have some publications that shows that you are research serious, that you want to really pursue a doctorate program. And you have to have a grade point average that satisfies the threshold of the PhD program.
Perfect. Thank you. We'll just go through. I think we're getting to almost all these questions. Thank you for everyone for sending those. The question here is, does USC Viterbi help graduate students prepare for their NCEES FE exam?
I'm not sure what NCEES is.
Sure either. If for that question, I'm going to pull up our the individual that asked that question can go ahead and email me and I can look into that further for you. In terms of the final question here, we will have this be our final question, Professor Modney. The question is, if your undergraduate degree is outside of the area of engineering, math, or a hard science, is admission to the degree program possible? And if so, what are you looking for?
Excellent question. From time to time, we have admitted people outside of engineering if they have a quantitative background. So we've had students who have come from a business school, but they've had some pretty solid quantitative mathematical foundation in statistics or data analytics and things of that nature. And of course, then in that case, because they show that they have the foundational work in the math, then we will admit them on a case-by-case basis.
Great, thank you. Well, that completes our presentation today. I want to thank everyone who attended today's session to learn a little bit more about the Systems Architecting and Engineering program. For those of you that attended live, thank you, and thank you for your questions. For those of you that might be reviewing a recording of this session, thank you for joining us today. Please do email any questions that you may have to those addresses that are provided on the screen here. We are always happy to connect with you, set up an appointment to chat, all of that at a later point in time. So please don't hesitate to reach out. Professor Modney, thank you so much for joining us today and for all of your wonderful information on the degree program. I really appreciate it.
I want to wish the attendees Yeah, I want to wish the attendees the best of luck, and I hope to see you in the program at some point in the near future. All right.
That sounds great.
Have a good
Thank
day.
you,
All
everyone.
right.
Have a wonderful
Okay.
day.